Okay, so today our learning goal states I can write and solve an algebraic equation to problem solve. So you're going to have to set up your own equations. And when I say an algebraic equation, what would have to be in that? There's a couple of different things that would help define an algebraic equation. What would be one thing that would have to be in your setup to be able to be considered an algebraic equation? Danny? A variable. Okay, a variable or variables, it depends on. Okay, what would be the other thing? The variable makes it the algebraic. What makes it an equation? Sylvia? An equal sign. We need the equal to sign in an equation. So algebraic means there should be a variable or some variables in there. And equal sign makes it an equation. So we are going to solve some word problems today, and that's what you're going to have to be. There's going to be some word problems in your homework for you to do also. So we're going to practice these. So it says, determine what is the unknown and assign it a variable to be used in an equation. Would you underline that, please? Determine what is the unknown and assign it a variable to be used in an equation. That's your first thing you're always going to do. After you've read through the problem and done some thinking about, like what are some of the important things in here and what can I eliminate, we need to give the unknown a variable. Okay, we're going to assign it a variable, and then we'll use it to set up and solve an equation. So who would like to read our first word problem for us out loud, please? Waiting on you. Sarah.
Dylan and his family live in a small town about 100 miles from Fargo. His family has lived there for more than 70 years, and his grandparents live close by. He is 3 times as old as his little sister Paige, plus 1 year. Dylan is just learning how to play the guitar. His birthday was last week. He turned 10 years old. How old is Paige?
Okay, thank you, Sierra. You know what, let's try that again, because I bet this is kind of how you feel. Derek, you read the first sentence. Paikea, you read the following. Tyler, you'll read the next one. We'll just wind our way around. But we're going to skip over Sierra if there's any sentences left. She's already done her reading. Each of you is going to read a sentence. So you're going to start, Derek. Go ahead. Read the same problem. You start.
Dylan and his family live in a small town about 100 miles from Fargo. His family.
Oh, no, you're only going to read one sentence. Paikea?
His family has lived there for more than 70 years, and his grandparents live close by.
He is 3 times as old as his little sister, plus Paige, plus 1 year.
Dylan is just learning how to play the guitar.
Sylvia? It's just after the guitar. This one, reading that sentence. Okay, and Sam.
He turned 10 years old.
And Katie. Took a whole lot of you to read through that word problem, didn't it? And that's kind of how you feel sometimes when you look at a word problem that's like, wow, there's a whole lot of stuff in there, isn't there? So we have to learn how to attack these and not let them shut us down right away. I've said this before, and say, you know what? I can't solve this. Oh my goodness, it's a lot of stuff. And so then sometimes what happens is because you have to solve it, then you just start pulling out all the numbers you see in it, and you start trying to do something with all those numbers. Anybody, does that sound familiar? Yeah. I can remember when that's what I used to do. I'd be like, oh, well, I'll just do this. I'll take this number. I need that somewhere, and I need this one somewhere, and I just pull them all out and just try something and get an answer. But we can figure out how to attack these word problems more systematically and decide, do all the numbers really need to be used? Have we done that before in here? Have we? Yeah, we've crossed out some numbers before that we haven't used in the problem, haven't we? So the first thing I want you to always do is this. Find out what they're asking you for. What are they asking us for in this problem? Danny? How old is Paige? Let's just circle that right now. How old is Paige? That's the real question. That's what we need to find. Okay, is there anywhere in there that it tells us how old Paige is. Does it? Probably not, or they wouldn't ask the question, right? But is there anything else involved in this problem that would help us find Paige's age? Sylvia?
That Dylan is 3 times as old as his little sister Paige plus 1 year.
Yeah, that seems like that's kind of important information that would help us. So let's underline that. He is 3 times as old as his little sister Paige plus 1 year. By the way, he is Dylan. Okay? Let's give he a name right there. Dylan is 3 times as old as his little sister Paige plus 1 year. Okay, is there anything else in there that you think looks like it might be kind of useful? Ikea?
He turned 10 years old.
He turned 10 years old. Okay, that seems pretty kind of an important piece also, doesn't it? Because it seems like Dylan is involved with his sister's age somehow, and if we know his age but we don't know her age, maybe there's a way we're going to be able to find her age. Okay, is there anything else you think is important in this problem besides those things? How about the fact that Dylan and his family live in a small town about 100 miles from Fargo? Do we need that 100 in our problem? No, just because it's a number doesn't mean we need it. Let's cross that sentence out. Dylan and his family live in a small town about 100 miles from Fargo. Who cares? How about the fact that his family has lived there for more than 70 years and his grandparents just happen to live close by? Do we need that 70 in our problem? No. It's nice that they've, gotten to be on the same farm for a long time, or in the same town, I mean, and that grandma and grandpa live close by. That's kind of cool, but it really doesn't matter in the picture of Paige's age. Okay. Well, then we'll skip over the sentence we underlined that we say we think is important. How about this? The one Dylan is just learning how to play the guitar. Does that have anything to do with figuring out Paige's age? No, it's kind of nice information if you want to know that Dylan is going to play the guitar and you like to play, and maybe someday you will play with him. I don't know. His birthday was last week. Well, that's kind of goes with the fact that he turned 10, right? But it really isn't, So we can just kind of leave that. We don't have to cross it out. It kind of goes with he turned 10 years old, doesn't it? Okay. Well. What's the unknown again? What is it that we're looking for? That's what we're going to assign our variables to. What are we looking for? How old is Paige? So let's call our variable x is Paige's age. So we start there. That's the part where it says how old is Paige. We circled it. That's what we need to find. That's what we're going to assign our variable to. So in fact, let's just circle that right now. Let's just say, you know what? That's what our problem is asking us for. Well then, let's write a word sentence that we can then replace with an algebraic sentence, an algebraic equation. So it says, Dylan is 3 times as old as his little sister Paige plus 1 year. Anybody know how we could write that in a word sentence and get rid of any extra words we really don't need? Could we say 3 times Paige's age? Dylan is 3 times as old as his little sister Paige. So that would mean if we would multiply Paige's age by 3 plus 1 year, is Dylan's age. That all right there describes Dylan's age. 3 times Paige's age plus 1 year is Dylan's age? Do you agree with me? Did we set that up in a word sentence pretty well from our problem? Okay, now let's start replacing it with numbers and variables and symbols and whatever it'll take to get in an algebraic equation. 3 times pages age. How could we write that? 3 times pages age. How can we write that? Ikea? 3x. Or 3 times x if you want to, kind of like go word for word. 3 times pages age. Well, pages age is x. Plus 1 year. What can we do there? Plus 1 is Dylan's age. Where would our equal sign go? Should this equal Dylan's age? Yeah. So is oftentimes is like our equal sign. Often, not always, but often it is our equal sign. So is Dylan's age. What are we going to put for Dylan's age? 10. He turned 10 last week. Remember, it was his birthday. Okay. So now we don't have any subtraction to change. So I'll just write it without a multiplication symbol. And do we have on the side where there is that addition, are those like terms? Can 3x and 1 be put together? No, these are 3 algebra x tiles and 1 unit little square tile. And then that's equal to 10 little unit square tiles on the right side of the equation. So we're ready to solve this. We don't have to do any cleaning it up, simplifying it. So those 3 x's, first of all, they say, get out of here, you 1 unit tile. What would we have to do? What would we have to add to that unit tile to get it to 0 pair? Okay, -1. So we're going to add -1 so that this will become a 0 pair. That's what we need. If we do it on one side, we have to do it on the other. We got to keep this balanced. And so now our equation reads what? 3x equals 10 plus a -1, 9. Okay, now we have 3 x tiles all by themselves and 9 unit tiles all by themselves on the other side of the equation. And we need to know Paige's age. Is Paige 3x? No, Paige is just one of those x's, isn't she? So what are we going to do next? Daniela? Divide both sides by 3. We need to divide these sides into equal groups. And we want an x in each group, just a 1x in each group. So we divide and we say one of our x's would be equal to what then? Each x would line up with how many unit tiles? Sylvia? 3. Okay, and now on these word problem ones, we're going to answer the question in a sentence. We're going to do some English practice here too. So what was the question again? How old is Paige? So is this Paige's age, or do we have to do something in? Is Paige 3? How do we know if she's 3 or not? Look up here. What's that saying? X is Paige's age. X is 3. Paige is 3 years old. Sentence, answer in the end. Now we ask ourselves, is our answer reasonable? Who was older in this problem? Do you think Dylan or Paige? Dylan. Well, how do we know it's Dylan? There's a word in there that helps us know that Dylan's older. Sylvia? Little sister, yeah. So she better be younger than him, right? Is she younger than him if she's 3? Yeah, she is. So it seems pretty reasonable what we got. We'd have ended up with an answer like 13. Would she be a little sister if he's 10? No, she'd be an older sister, wouldn't she? Okay, so we also want to always make sure that we ask ourselves, does my answer seem reasonable? Whenever we do word problems, don't be just happy to have an answer. Questions, anyone? We're going to be doing a lot of word problems this week, so. Okay, then let's go to number 2. We got Hector, who likes to collect cars. Okay, so Hannah, would you start reading, and let's just take this apart one sentence at a time right now again. So Hannah, you start. Caden, Sam, Sylvia, Sierra, and then I don't know how many will be left. Go, Sam or Hannah.
Hector likes to collect old cars and fix them up.
Some of his cars are from the 1970s.
He has a black pickup truck that is 12 times as old as the sports car that he drives around in every day. The pickup truck
Pretty.
is pretty
Beat up.
beat up and
And has.
lots of damage.
Yes. And lots of dents. Okay, Sierra.
His sports car is in good condition.
Danny. And Tyler.
All of his are just pickup truck.
Okay, a whole bunch of stuff here, right? Okay. As we were reading through that, did you already say to yourself, there's some information in here that I really don't think is important? Like what? He likes to collect old cars and fix them up. That's not going to help us solve our problem, is it? Okay, so. But really, what's the first thing we should do before we even start deciding that? What do I say we should do? IKEA?
Circle the question.
Yeah, circle the question. What do they want us to find? So, what do they want us to find?
How old is Hector?
Yep. How old is Hector's pickup truck? Well, the age of his pickup truck doesn't necessarily, doesn't necessarily jive with, he likes to collect, other than, old, it probably should be old. And fixing them up, well, yeah, it's just something he likes to do, it is a hobby. Is there anything else you think is kind of useless? Hannah?
Some of his cars are from the 1970s.
Yeah, some of his cars are from the 1970s. Well, that's cool. That was the decade I graduated from high school. That's a great decade. But other than that, it's not really useful for anything. Okay, and anything else you think might be useless in here? Caden?
Because of the two that I have, or just the one.
Which one?
Can I say the 2 sentences I have, or just the one?
One.
The pickup truck is pretty beat up and there's lots of dents.
Yeah, okay. The fact that it has a bunch of dents and is beat up that just means he has lots of fixing to do, right? Sam?
His sports car is in good condition.
Okay, his sports car is in good condition. Okay, so. Anything else? Okay, well, then maybe we now need to start underlining the stuff that is important, huh? So what do you think is important in this one? What would be one of the things that's kind of important in here? That they tell us? Caden?
He has a black pickup truck that is 12 times as old as the sports car he drives around in every day.
Okay, so I don't really care about the color. I'm going to say the pickup truck that is 12 times as old as the sports car. Do we need anything else? That he drives around in every day? Does that matter? Okay. Danny? What's it? The car. So you know what? We need to go back here and we need to kind of like underline that sports car so that we know that that's the it. The sports car is only 3 years old. Okay? Whenever there's an it involved, we have to make sure we understand what the it is. Okay? Okay, so we're going to assign a variable to the unknown. What's going to be our x this time? X is what? Okay, what about the pickup truck? Is the age of pickup truck, right? It says how old. How old is Hector's pickup truck? So X is age of pickup truck. And we're just gonna take this one right up here. It says pickup truck is 12 times as old as the sports car. Let's write that down. Pickup, we'll leave out the word truck right now, is 12 times as old as what?
This is sports car.
As sports car. Pickup is, the age of the pickup is 12 times as old as the sports car. Is that what it said? Pickup truck is 12 times as old as the sports car. So sometimes when you take the time to write down the words, you're gonna set yourself up for more success being able to write the equation. Would you write an equation now you think that will replace that word sentence? Just try one. You can erase it if it's wrong when we reveal what we think it should be. But I want everybody to write one. Write your own equation. So line up some numbers, symbols, the variable, all underneath parts of that word sentence. Can be replaced with that. Roman, tell me what you wrote down. Well, you need to write something down. I told everybody to. Danny, tell me what you wrote down. 12x plus 3, like this. Is that an equation, class? Why not? You meant equals 3. So now you're going to change the plus sign to an equals? I just want to make sure I do the right thing. Well, we need an equal sign in it, right? So let's see where would if we stick an equal sign there, let's see if that would, those words would replace. 12 times as old as the sports car. So 12 times, so is X the age of the sports car? 12 times as old as the sports car. Is X the age of the sports car? No. That's the age of the pickup truck. Kaden?
12 times 3 is
So 12 times 3, the age of the sports car, is the age of the pickup. What would we put over here then? X. We don't know how old the pickup is, do we? So this time the X is over there by itself already. So the pickup's age is 12 times as old as the sports car. The sports car is 3 years old. Well, we should be able to do this without even having to think about keeping a balance, shouldn't we? 12 times 3 class is? 36. So what does that tell us? What are you going to write for a sentence in this one? Kaden?
The pickup truck is 36 years old.
The pickup truck is 36 years old. Does that seem reasonable? What do you think? Let's go back to our problem up here and see. He likes to collect old cars and fix them up. Well, this pickup definitely needs fixing up, doesn't it? It has lots of dents. Is it old? Yeah. In fact, it's older than the sports car, right? Okay. So, do we have a reasonable answer, do you think? Yeah? I didn't ask you if we have a right answer, I'm asking if we have a reasonable answer. There, you know, the reasonableness helps us get better at getting them right. We have to make sure that they're reasonable. Okay, questions, anyone? Let's go to the back side where we have one more to do. Okay. I want you to read this one to yourself. I want you to circle what you think our variables are going to represent in this one. Okay, everybody, it's a big circle. That's all I want right now. Something circled. There was a whole lot of stuff in this problem. What did you circle? There shouldn't be a whole sentence, by the way. Sierra? How old is Brian? That's the only thing that you needed to search. How old is Brian? That's what we need to find. So what are we going to call that? X. X is what? Brian's age. Okay, now you can start deciding what should we cross out and what should we underline. So, anybody want to give us an idea of what's something we could either cross out or that we should underline because we need it? Come up with something for me, Derek. By the way, just in case you don't think this is right, Mr. Williams happens to be Brian's dad. Okay. In this problem. Got anything for me, Dirk? Not yet. Hannah? Mr. Williams and his wife have 3 children. Is that something we should underline or cross out? What have you decided? Is that important to this problem or not important? Not important. If we decide it's not important, we cross it out. Okay. Tyler.
Brian is in high school and wants to play basketball.
Okay. Or baseball. Yeah. Brian is in high school, loves to play baseball. Do you want to keep that or cross that out? Cross that out. Okay. I'm thinking that maybe one part of that might come in handy when we were figuring reasonableness, but right now it's not important for solving the problem, is it? Okay, Caden? We should probably leave that Brian is in high school. Okay, so in other words, it's kind of like when we're done and we get an answer, he should probably not be like 5, right? Unless he's a crazy genius in high school at 5. Okay, something else. Ikea?
His dad was 41 years old.
Keep it or get rid of it? Keep it. His dad is 41 years old. Ikea says that's important. I think I agree. Sierra?
Mr. Williams is twice as old as his son Brian, plus 13 years old.
Okay, so is that important or get rid of it? Important. Mr. Williams is twice as old as his son Brian plus 13 years. Remember, Mr. Williams is who? His dad. Okay. I think there's a couple of sentences left in there. We gotta decide if they're important or not. Tyler?
Gina is the youngest child and is still in elementary school.
Okay.
It's not important.
That's not important. Nothing in here talks about Gina other than that, right? She's one of the 3 kids, though, isn't she? Okay. And Caden?
Each child was born 2 years apart.
Okay. Is that important? We need that 2 in there. Everybody agree? Each child. Sam says no. Why not, Sam? We need an equation for this one, but you're saying we don't need the 2 in the equation? Because is there anything in there, anybody involved in this other than the dad and Brian? No, they're the only people involved in this really, even though there's a whole bunch of other information here for us. So we really can cross that out. It's really not gonna get used, I don't think. Okay, so now we're gonna take what we have underlined and see if we can write a word sentence. We're gonna call Mr. Williams Dad. We're gonna say Dad is twice as old means 2 times, right? Do you agree with me on that? Twice means 2 times. 2 times as old as Brian plus, oh, I should have been writing smaller so I could have gotten it all on one line. Oh well. Plus 13 years. Okay, write an equation. Go. We give you 1 minute. Replace that word sentence with an algebraic sentence. So don't give any more information on the word sentence to help you set up the equation that you're going to replace with numbers, symbols, and the variable. Okay, what'd you write, Hannah?
2 times x plus 13.
That's it? Okay, we need an equation, so can somebody finish it off here maybe, Ikea? Equals 41, okay, because it says right here, Dad is, so Dad's age is 41, is equals, so Dad's age is twice Brian's age, 2 times as old as Brian, plus 13. Looks good, doesn't it? Okay. So I'm just going to clean it up a little bit and make it 2x, and that's probably even how Hannah told me it. And I have to decide, is there anything I need to do on either side to simplify it first? In other words, I don't do it to both sides, I just do it on that one side. Is there anything I can do? Can we add 2x and 13 together? No. Okay, and 41's already by itself, so we're ready to solve this. So it's like we have all these algebra tiles on our desk. What are we going to do first? What needs to go first? Should we get rid of the 41? Should we get rid of the 2x? Should we get rid of the 13? Little hint. The x tiles want to be alone. They do not want anything on that side with them. Hayden? Yeah, we need to get rid of the 13. We need something that will zero pair those guys out, so we need 13 negative tiles. And if we add them to one side, we have to add them to the other side to keep it balanced. Well, over here, they zero pair out all of those. We have 13 zero pairs. And we end up with 2x by itself over here, don't we? What's going to happen over here? We have 13 red tiles that are going to do what? Zero out with 13 tan tiles. So these 13 negative reds have to have 13 tans. Do we have 13 tan ones? Yeah, we have 41 of them, don't we? So we're going to take 13 of those away from it. We're going to say, I need to steal 13 of them so I can zero out that negative 13 here. So what do you get? 28, okay? So this side of the equation becomes 28. Now what are we going to do? Now what, Ikea?
Divide 2 on each side.
Yeah, we need to divide each side into equal groups, 2 equal groups, because there's 2 x's, and we end up with each X being lined up with how many units? Danny? 14, 28, so it's kind of like you gotta go and divide 28 by 2 and get 14. Okay, what's that tell us? You just found X equals 14. Okay, big deal, what is that? Heck yeah.
Brian's age.
That's Brian's age. Remember back up here, it says that X is Brian's age, and is that what we were supposed to find? How old is Brian? So we're gonna say Brian is, how old?
14.
14 years old. Brian is 14 years old. Does that seem reasonable? Why? What they tell us in this problem that says, you know what, I kind of like that I got 14. Tyler?
He's still, he's in high school.
He's in high school. Can you be in high school when you're 14? Yeah, you can. You could be a ninth grader and be 14. Did you know that? Yeah, okay. Yeah, he could be in high school and be 14. So that seems more reasonable than if he would have turned out 4, right? If we would have gotten Brian as 4, would that have been a problem? We probably should have said, hey, wait a minute. Brian's in high school, not in preschool. Okay, so, okay, anybody have questions? I am counting on you to persevere and attack these word problems confidently like we did today. You can do it. We're not going to just do them to do them anymore, okay? Get out some loose leaf.